We are going to discuss some operators in C language. Operators are classified into three types. They are unary operators, binary operators, and ternary operators or conditional operator. Here, for example, A plus B. Here, plus is the operator, A and B are the operands. In A plus B, plus is the operator, A and B are the operands. Here, this A plus B is the expression. In this expression, we have operands and operator. Okay, now we are going to see how the operators are classified into three types: unary operators, binary operators, and ternary operators. You see here, first one, unary operators. Unary means single operator. Here, you see here, it will work on only single operand. For example, A plus plus. That means A value will be incremented, or plus plus A. Okay, this is the pre-increment, plus plus A plus plus post increment. So this operator will work on single operand. Okay, similarly minus minus also. Next, not operator. Okay, so A not. Okay, you see here example for unary operator, x is equal to minus y plus z. Here you see that minus operator will work on operand y. So this is the unary minus operator. Okay, next, increment operator. You see here, I is equal to, here we have two types of increment operators: pre-increment operator, example plus A, post increment operator, A plus plus. Okay, you see here, I is equal to 10, sum is plus I. You see here, now at the beginning the value will be 10 only. Later, whenever we display the sum, then the value will become as 11. You see here, sum is 11. Okay, actually I is, you see here, sum is equal to plus I. Now the sum is 11. Okay, you see here, I is 10, sum is I plus plus. Okay, for this you will understand in a program. I will show this example, this pre-increment operator and post-increment operator in the example. Okay, you see here, example, A is equal to 10, plus A. This is the pre-increment operator. Pre. To this operand, operator is there left side, so it is pre-increment. If the operator is right side, that is post-increment operator. Okay, so here A is the 10 plus A. That means A value will become as 11. Now A is 11. If I give plus A once again, 11 will become as 12. Okay, 11 plus 12, 23. You see here example. In the example of the program, A is 4. Okay, you see here A value will be displayed. What is the A? 4. Next, A plus. Here this is the post increment operator. Okay, in the post increment operator, it takes some time. Okay, A plus is same 4 only. Whenever we display the A value, then that A becomes 5. So in the post increment, it takes some time. But whereas in the case of pre-increment operator, immediately the effect will be happened. The effect will be done immediately in the pre-increment. But this is the post-increment. Immediately the effect will not be. A is the 4, na? A plus. Slow process in the post-increment. Whenever we display A, the value will become 5. Okay. But whereas in the case of here, for example, A value, A is the 4. If I give plus A, immediately it will become as 5. Why? Because that is the pre-increment operator. But here it is post-increment operator. In the post-increment operator, it takes some time. If I give plus A, immediately A 4 becomes as 5. But it is A plus. Now this value is 4 only. After that, whenever we give the A, from 4 to 5, the A value will become as 5. Okay. So this is the post-increment operator program. This is the example. P is 2, Q is 3. Okay, plus P. What is the P? 2. Immediately pre-increment, immediately the effect will be there. Here Q is 3, plus Q. Immediately the effect will be there. Okay, 3 plus 4. What is the R value? 7. Similarly, here also P value. What is the P? Now, here P is 3, 3. Here plus Q. What is the Q value? 4. So, now if we give plus Q, 5. 3 plus 5, 8. Okay, here what is the R value? 7 will be displayed here. S value, what is that? 8. 8 will be displayed here. Here this slash T means 7 character space. Okay. In the decrement also, in decrement operator, we have pre-decrement operator and post-decrement operator. Next, binary operators. Here in this binary operators, 2 operands, 1 operator. Earlier in the unary operator, plus a, minus a, plus a, okay, like that. They are unary operators. On a single operand, if the operator will function, that is the unary. But here, 2 operands. Earlier in unary, only 1 operand. But in binary, 2 operands, a plus b. That means 2 operands, 1 operator. Okay, here binary operators are classified into arithmetic operators, relational operators, logical operators, bitwise operators, assignment operators. You see here arithmetic operators. You see here arithmetic operators are plus, minus, asterisk, multiplication, division. Okay, this division operator gives quotient. This modulus operator will give remainder. Okay, these are the arithmetic operators on expression. To evaluate the expression, we use these arithmetic operators. Okay, this is the program for arithmetic operators. You see here p is 10, q is 20, r is 10, x, y, z, p plus q. Okay, these operation values will be displayed here. Q by r, here it gives only quotient value. Q by r, 20 by 10. Okay, 10 to the 20. Our quotient is 2 na. Okay, so y value will be displayed as 2. R modulus q. Here this modulus operator will give remainder. Okay, what is the r? 10 by q. Okay, so here it gives remainder value. You see here a into b we can write as a asterisk operator b. X minus y by z we have to write like this for the expressions. Okay, to evaluate the expressions we have to write in our programming language like this. For 3x plus 2 into 4y we have to write like this. Okay, exponential of absolute of a we will write like this. Okay, a to the power of 4, power of a comma 4, like that we have to write. Okay, you see here a modulus b, 20 modulus 10, remainder 0. A by b, 20 by 10, quotient 2. Okay, you see here in the float 5.0 by 2.0 we can get the quotient as 2, but for modulus operator we cannot give like this. In floating point values we cannot give for modulus operator. Next, relational operator. In binary operator, this relational operators is one of the binary operators. Relational, it will compare the relation. Okay, it is used to compare the relation between 2 operands. Okay, you see here it represents true or false only. Less than operator, less than or equal, greater than or equal operator. This is the equal operator. This is not equal operator. You see here program for relational operators, p is 10, q is 20, r is 10. Okay, x is p greater than q. Okay, what is the p? 10, q 20. 10 greater than 20, false. So if I give, what is the x value? False means 0. Here x value 0 will be displayed. If it is true, 1 will be displayed. If it is false, if it is true, 1, false, 0 will be displayed. Okay, relational operators used to compare. Okay, next, logical operators. You see here it is used to take decision to connect one or more relational expressions. Result of the operator is either true or false. You see here logical and, logical or, logical not. What is the AND condition? True and true, true. In remaining cases, false. In logical OR, at least one should be true, unless it will be false. In logical NOT, if it is true, result is false. If the A is true, not A is false. If the A is false, not A is true. Okay. For logical operators, you see here, A is 2, B is 4, C is 3, D. A and B. This is the double ampersand is the AND. Okay. 2, 4. 2 and 4. Okay. 2 is true. 4 is true. True and true. True. That means 1. Here you see. Here you see 3 and B value 4. Not 4. Not 4 means false. 4 is true. Not 4 means false. False means 0. Here 3. True and false. False. Okay. Here true and true. True. True or false. True. Okay. That is the answer. Okay. Next. Bitwise operators. Here bitwise operators. Data items are stored in memory as sequence of bits, zeros and ones. We can manipulate these bits by using some applications. Programmer directly interact with the hardware of a system through bitwise operators. Okay. For machine language, we have to use these bitwise operators. Okay. Here we have 6 operators. Okay. To understand machine language, in bitwise operators, we can understand. Okay. Bitwise operators are used in to convert machine language. You see here, this is the bitwise AND, bitwise OR, bitwise exclusive OR, tilde operator ones complement, left shift, right shift. You see here bitwise AND. For example, A is 2. 2 means, you see here, 2 means in binary language, like this we can write. Okay. Next for 3, we can write like this in binary language. Okay. Now, for this bitwise AND, you see here, this is the A value, this is the B value. A and B. False and true. False and true is false. True and true is true. Like that. We will do that. Next bitwise OR. You see here, at least one should be true. Then result is true. Here you see false and true, true. True and true, true or false or true, true. True or true, true. At least false or false, false. At least one should true. Then total answer will be true only. Exclusive OR, bitwise exclusive OR, XOR operator. Here you see here, if both are same, that is false. Both are true, false. Both are false, false. If both are same, false. Okay. Remaining cases, true. Same here also. You see here, if both are same, then only false. Unless true, you see a different one. 1. Okay. False, XOR true, true. If both are same, false. For bitwise exclusive OR, okay, both the bits are true, then it will be false. If both the bits are false, then result is false. Okay, next bitwise ones complement. Okay, this is the tilde operator. Negation of 0 is 1. Negation of 1 is 0. Negation of negation I. Okay, you see here for I5 in binary language we can write like this 101. Okay, this is the negation opposite. For one opposite of 1, 0. Opposite of 0, 1. Opposite of 1, 0. Like that we write. Next, left shift operator and right shift operator. You see here, I will explain example. You see here, left shift and right shift operators are used in multiplication and division. Okay. You see here, this is the example. You see here, example for left shift and right shift operators. A is 5, B is 8, C comma D. You see here, A left shift of 2. That means A is 5. For 5 we can write in binary language 101. Okay. Here for this we are going to do the operation of left shift 2. Okay. Here 2 bits we have to shift to the left side for this. If we shift 2 bits to the left side, then here we have lack of 2 bits. So right side you add 2 bits. Right side I added. I shifted these bits to the left side, 2 bits. A left shift to 2 na. So I have to shift 2 bits to the left side. Then here we should have 8. 1, 2, 3, 4, 5, 6 only. So I want 2 more bits. For that purpose, I will add 2 bits to the right side. Next, 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, like that. Total 8 bits na, 2 to the power of 7. Okay. 2 to the power of 7 into 0 plus 2 to the power of 6 into 0 plus 2 to the power of 5 into 0. Like that, we have to do the calculation. Then we will get the 20 answer. You see here, B right shift 1. Here, what is the value of B? 8. We can write like this, 0, 0, 0, 0, 1, 0, 0. Here, right shift. We have to shift 1 bit, right shift of 1. So 1 bit, we have to shift to the right side. Then here, I want 1 bit, total 8 bits now. We shifted 1 bit to the right side. I want 1 bit for the calculation. That's why I added 1 bit 0 to the left side. Okay, next. 2 to the power of 0, 2 to the power of 1, like that we have to write 2 to the power of 7. You see here 2 to the power of 7 into 0 plus 2 to the power of 6 into 0 plus 2 to the power of 5 into 0 plus 2 to the power of 4 into 0 plus 2 to the power of 3 into 0. Like that we have to write. Then we calculate the expression. Then we will get the 4 answer. Okay. You see here. You see here, this is right shift. What is the B value? 8. If I, what I got? Answer 4. This right shift is used in the machine language for division. Here, what is that? 1. Whatever it is, we have to do with the 2 only. Here, 1 time. So, 8 by 2. What is the answer? 4. Right shift for division. Left shift for multiplication. What is the A value? 5. How many times I have to multiply? 2 times. 5 into 2, 10. 10 into 2, 20. That's why we got C is 20. So left shift for multiplication, right shift for division. In machine language, we use like that. This is the left shift and right shift operators. Next, assignment operators. Okay, assignment operators are used to here you see here assignment operators are used to assign the value to a variable. Assignment operators are used to assign the values to a variable. We can assign the values to the variable. You see here, plus is equal to x is equal to x plus y, minus is equal to multiplication, asterisk operator, star is equal to, slash is equal to, modulo operator is equal to. You see here x is 10, x plus is equal to 3. That means x plus is equal to 3 means x is equal to x plus 3. What is the x value? 10. 10 plus 3, 13. You see here, program for assignment operators. You see here, A is 3, B is 5, C is 3, D is 4. A plus is equal to 1. The meaning of this is A is equal to A plus 1. What is the A value? 3. 3 is equal, A is equal to 3 plus 1. What is the A value? 4. You see here, 4. Like that. B minus is equal to B means B is equal to B minus B. What is the B value? 5. 5 minus 5, 0. B value is 0. Like that, we write the program. Next, ternary operator. Earlier, we discussed binary. Here, ternary operator. In this, we have 3 expressions. Okay, it's a conditional operator denoted by question mark and colon. Here, 3 operands will be there. Okay. In between 2 operators, 3 operands. You see here, example for this. You see here, if we see the program, then we can understand. You see here, P is equal to 4, Q is 5, min. P less than Q, question mark, P colon Q. You see here, this is the first expression, this is the second expression, this is the third expression. If it is true, this condition, this first expression is true, then this will be evaluated. If this condition is false, first expression is false, then third operand will be considered. Okay, you see here, P is the 4, Q is the 5. Is 4 less than 5? Yes, it is true. If it is true, first expression is true, we consider second one. If the first expression is false, we consider third one. If the first expression here 4 less than 5, yes, true. If it is true, second expression will be considered, second operand. Okay, so what is the P? 4. That 4 will be assigned to min. Smallest value is percentage d comma min. Here minimum. What is the value here? 4, min value. 4 will be displayed here. Okay, so this is the ternary operator. 3. You see here in this expression, 1, 2, 3 operands, 3 expressions, and 2 operators, question and colon. 3 operands, 2 operators, 3 expressions, first expression, second expression, third expression. If the first expression is true, second expression will be evaluated or considered. If the first expression is false, third one will be considered. Okay. Next, one more example. For ternary operator, x is 3, y is 9, z is 4, p. X greater than y. If it is true, then x will be considered. If it is false, next expression will be considered. Okay. If it is considered, then if it is true, y will be considered. If it is false, z will be considered, like that. Okay. In this, you see here, for this first expression, second expression, third expression. What is the x? 3 greater than 9. Is it true? No. 3 greater than 9, not. False. So we will go here. This will not be considered. This will be considered. Y greater than z. 9 greater than 4? Yes. So if it is true, y will be considered. What is the y value? 9. 9 will be assigned to p. Greatest number is p. You see here output. Next, moreover with this unary, binary, ternary operator, we have special operators, comma operator, size of operator, address operator, pointer operator. Okay, like this in expression we can use comma operator. Sum is equal to x is 2, y is 3, x plus y. evaluation from left to right. Okay. Next, size of operator. You see here float x, size of x. What is the float value? 4. Y is 4 bytes. Okay, you see here, this is the program for the size of operator. A is 10, B is 15.9, C is character A. A is size of A. Size of is the operator. We cannot give the space. Size of A. What is the size of A? 2 bytes, integer size. The size of operator gives the size of the data type. Okay, size of B, float. B is the float, no? Character size 1 byte. Size of C, 1 byte. Next, pointer operator, it returns address of the another value. In the next further classes, you will understand pointer operator, address operator. It is used to store the values. Later, you will understand these operators in further programs. Okay. You see here address operator, C is 10, address of C. Okay. The format specifier, type specifier for the address is %u. Okay. Where the 10 is stored, the address of the location we display. Okay. The address of the location will be displayed here. You see here address of C, the location address, the value address. Okay, that address of pointer refers value. Okay, that address of value is 10. Okay, in further classes you will understand this. Okay, thank you for watching. If you like it, please share and subscribe.